All right, Boyle's law was concerned with pressure and volume. Charles' law is concerned with volume and temperature. And if you'll think about it for a second, you know already that when you heat things up, they expand. In other words, you increase the temperature, you increase the volume. They're directly proportional. If you cool things down, they contract. You reduce the temperature, you reduce the volume. They're directly proportional. And so that's what Charles' law says in mathematical terms. So the equation for Charles' law, and again, the temperature has to be in kelvins, or this form of the equation will not work. No kidding. Do not pass go, do not collect $200. The equation says that the first volume divided by the first temperature is equal to the second volume divided by the second temperature. And that's Charles' law. Also, very simple, very straightforward. Let's put a little note over here, though, that the temperature must be in kelvins. Otherwise, if it were freezing, you might wind up dividing by 0, and that's a no, no, no. Don't do that. Okay, for example, let's suppose alright, we have a 2-liter balloon. That's a modest little balloon at room temperature, which is usually considered 22 degrees Celsius. And little Charles decides he loves this balloon and he wants to take it home from the party with him, so he tucks it underneath his shirt and it warms up to body temperature, 37 degrees Celsius. How big is this balloon going to be? All right, as we read along, let's list our numbers. Our first volume is 2 liters. Our first temperature is 22 degrees Celsius. And you say, but, you said the temperature has to be in kelvins. Well, so it does. And so to this, we're going to have to add 273 to convert that into kelvins. And I find that it prevents trouble if I go ahead and do that the second I write it down. As we're reading along, then we find that our second temperature is 37 degrees Celsius. And again, that's not legal. We're going to have to add 273 to it, which comes out to 310 Kelvin, which sounds like a bodacious fever, but in fact it's pretty normal. We are being asked for its volume in this second set of circumstances. So again, we've changed a word problem into a list. We just look down these variables and say, oh, I know what this is. This is a Charles' law problem. Tell me so, and then substitute in the numbers. And then you can cross multiply and divide and do all that in your calculator. No muss, no fuss. And we'll find that our new volume is 2.1 liters. If he can get away with the 2-liter balloon at the beginning, he'll be able to get away with the 2.1-liter balloon at the end. No problem. All right, we're not going to do an entire lesson on it, but there's also a little nugget called Gay-Lussac's law. Gay-Lussac's law deals with pressure and temperature. Of course, as you heat up a gas and the particles are moving faster, they're going to smack into the walls harder and increase the pressure. And so it winds up being, and again, the temperature must be in kelvins in order to use this nice simple form of the law. And I won't insult your intelligence by dragging you through an example of this. It's just plug and chug. So we'll stop there.